In March 1945, operations were underway along the Rhine River, where Allied troops faced the possibility of running into the latest German armor. As American tanks pushed through city streets, there was a real chance they would meet a heavy assault vehicle built on the chassis of the Tiger tank. This machine stood out from standard models because it lacked a conventional gun. Instead, a massive caliber launcher was mounted in its superstructure. The firepower of this weapon was enough to knock out a group of armored vehicles with a single shot. We are talking about the Sturmtiger, a specialized vehicle designed for street fighting that only reached the front lines in the war's final stages. The story of this project began in the spring of 1943, when the strategic situation called for a change in how battles were fought. After the battles of Stalingrad and Kursk, the front line was gradually shifting west, and fighting in large urban areas was becoming increasingly intense. Using classic field artillery to storm fortified buildings proved ineffective because moving guns under fire was difficult and the crews were too vulnerable. There was an urgent need for a radically new type of weapon, mobile, heavily armored, and capable of demolishing solid structures. Engineers proposed creating an assault vehicle on the heavy Tiger tank chassis, equipped with a 210mm howitzer. The initial project was approved, but technical implementation dragged on. Designers faced a number of problems, particularly regarding recoil compensation for such a powerful gun and fitting the ammunition inside the hull. Since the situation at the front demanded quick solutions, Minister of Armaments Albert Speer intervened on April 11, 1943. To speed up development, it was proposed to use an existing system, a 380mm rocket projector, initially developed for the Navy, specifically to arm patrol boats, but which had never gone into mass production. The launchers were sitting in warehouses, and their projectiles packed massive destructive power thanks to a heavy payload of explosives. Speer presented this concept to the High Command, proposing the integration of a naval weapon onto a tank chassis. The idea of creating a heavy vehicle capable of destroying fortifications and buildings with a single shot was approved and given development priority. By August 5, 1943, the final version of the vehicle was presented, designated as the Sturmpanzer VI, but better known as the Sturmtiger. Plans were made for small-scale production, but a question arose regarding the feasibility of using new chassis. Pulling new tanks off the production lines could negatively impact the supply of standard Tigers to the front, where the demand remained high. A solution was found in logistics and repair. They decided to build the assault units using the chassis of tanks, returning from the front for major overhauls. Damaged vehicles requiring parts replacement or hull repairs underwent extensive modernization, during which they were fitted with a new superstructure and the rocket weaponry. On October 20, 1943, Alket presented the first prototype to the customer. The machine was distinguished by a massive, fixed superstructure made of unarmored steel, mounted on a Tiger hull, with a large opening for the mortar in the front plate. The military noted the sheer size of the vehicle, but insisted on trials. Testing exposed technical flaws, firing accuracy was low, and the reload cycle was long. After a detailed inspection, the Commission recorded these issues, leading to the need for significant modifications. The production superstructure was made from proper armor steel, almost 6 inches thick on the front, offering protection against most anti-tank guns of that period. The Raketenwerfer 61 mortar was installed in a ball mount that allowed vertical aiming from 0 to plus 85 degrees and horizontally within a range of plus or minus 10 degrees. To shift the sector of fire significantly, the entire hull, weighing over 33 tons, had to be pivoted. The rocket projectiles had a complex design and substantial mass, 774 pounds. Handling such a load with a crew of 5 in such a confined space, was a difficult task. The rocket was stabilized in flight by rotation, provided by the angled arrangement of the engine nozzles and lugs on the body that engaged the barrel's rifling. The muzzle velocity of the projectile leaving the barrel was 984 feet per second. The warhead of each rocket packed 275 pounds of TNT, powerful enough to demolish a 3-story building. On paper, the ammunition load consisted of 14 rockets, 12 stowed in racks on both sides of the superstructure, 1 on the loading tray and 1 directly in the barrel. In practice, crews often loaded 13 shells, leaving the loading tray free to optimize working space. The reloading process was extremely labor-intensive. In cramped and fume-filled conditions, the crew had to pull a heavy rocket from the rack, move it to the tray, hoist it, and ram it into the barrel. This procedure took anywhere from 5 to 10 minutes, depending on the crew's training and the immediate situation. Production of the Sturmtigers began in August 1944, when the first batch of 12 vehicles rolled off the assembly line. Work was completed by September 21st, and on October 6th of that year, the new self-propelled gun was officially accepted into service. By then, the strategic situation on the fronts had deteriorated significantly. In the east, the Soviet offensive continued. In the west, Allied forces were advancing from Normandy toward the German borders. German troops were retreating, losing equipment and personnel in encirclements. The number of operational Tiger tanks suitable for conversion was shrinking rapidly, while damaged vehicles were previously evacuated to the rear for repair. During the rapid retreat, many machines had to be destroyed on the spot to prevent them from being captured by the enemy. Recovery units often couldn't keep up with their tasks, and there was a critical shortage of fuel for towing heavy equipment. As a result, the second batch consisted of only 5 units and was ready in December 1944. In total, from October 1943 to December 1944, 18 vehicles were manufactured, counting the prototype, which was later fitted with a standard armored superstructure. This number was far below the planned 10 units per month, but given the industrial crisis, airstrikes and resource shortages, even this volume was considered a result. Crews for the new equipment were trained in the 500th Independent Heavy Tank Battalion, which had been repurposed for these tasks. The battalion developed deployment tactics, drew up instructions, and conducted training. According to the documentation, the vehicle was intended to destroy barricades, buildings, and fortifications during street fighting. The high-explosive rocket could also be used against concentrations of enemy troops. A single hit guaranteed destruction within a 55-yard radius. At the same time, firing at individual, small targets wasn't recommended due to the high cost of ammunition and the weapon's specific accuracy issues. On August 1st, 1944, the uprising began in Warsaw. Polish forces decided to liberate the capital on their own before the arrival of Soviet troops, who were stationed on the opposite bank of the Vistula. Units of the Home Army occupied districts of the city, erected barricades and organized defenses inside solid buildings. The German garrison found itself in a difficult situation. Combat operations against the insurgents in the dense urban environment were complicated. Every street and every building was being used for defense. Command was looking for ways to turn the tide. Using field artillery for direct fire carried high risks due to sniper fire and anti-tank weapons. Airstrikes destroyed entire blocks, but the ruins often created new cover for the defenders. In this situation, it was decided to bring in the Sturmtiger prototype, which was undergoing proving ground tests. At that time, the machine didn't even have its standard armored superstructure. Instead, a temporary structure made of ordinary steel was installed. On August 12th, the prototype was loaded onto a railway flat car along with a stock of 12 rockets, and sent to Warsaw. On August 13th, the equipment arrived at its deployment site and was immediately thrown into combat in the Starówka district and along the Vistula. The crew received orders to methodically demolish buildings where enemy forces had entrenched themselves, destroying their fortifications. On August 19th, the prototype assault launcher opened fire on combat targets for the first time. The blast wave from the shot was massive, shattering windows within a radius of several blocks, while the vehicle itself, even with its tracks locked, would roll backward. The rocket's flight left a smoke trail, followed by a powerful explosion. Multi-story structures suffered critical damage. Walls collapsed and floors caved in, leading to casualties among those who hadn't managed to leave the premises. However, during operation, it became clear that the weapon's actual effectiveness differed from what was planned. Flaws detected back at the proving ground were confirmed in combat conditions. Firing accuracy turned out to be poor. Rocket deviation reached tens of yards, and sometimes the shells strayed significantly from the target. When firing from a distance of over 160 yards, hitting a specific building became problematic. A separate technical issue was the rocket fuses, which were designed to penetrate reinforced concrete fortifications, bunkers and pillboxes with significantly thick walls. It was intended that detonation would occur only after the obstacle had been penetrated. Since Warsaw's buildings were mostly brick structures with relatively thin walls, the shell would often punch right through the obstacle, fly out the opposite side, and explode in an open area or the next block over. There were cases where the munition didn't detonate at all, burying itself in the ground. Resistance fighters eventually realized that staying inside stone buildings could actually be safer than being out in the open. The crews of the self-propelled guns reported this ammunition mismatch and requested more effective means of destruction. Eventually, a shipment of rockets with more sensitive detonators was arranged, ones that would trigger upon contact with less substantial obstacles. These shells arrived in Warsaw on August 18th, changing the situation. Now the rockets exploded upon hitting a building, causing significant destruction. Between August 15th and 18th, the prototype was joined by the first production model, Sturmtiger, a vehicle with a fully armored superstructure and increased ammunition capacity. This allowed for intensified fire on positions. The two vehicles moved through the streets, maneuvering and firing. The reloading process took a long time, from 5 to 10 minutes, due to the difficulty of handling a 770-pound shell within the confined space of the superstructure. With the use of the new detonators, effectiveness increased. Buildings were destroyed, forcing the enemy to take casualties or retreat. The two units operated in Warsaw until August 28th, using up their entire available ammunition supply. This period became the only example of these vehicles being used for their direct purpose, assaulting a fortified city. Even under such conditions, the machinery demonstrated a number of flaws that affected the overall assessment of its firepower. Based on this experience, Command made the decision to form specialized units. Production vehicles began arriving at the 1001st, 1002nd, and 1003rd Assault Companies, which were created specifically for this type of weaponry. The staffing table called for 14 units of equipment in each company, but reaching that number proved impossible due to a shortage of manufactured vehicles. In reality, units were outfitted with 3 or 4 self-propelled guns, and sometimes even fewer. The 1001st Company was redeployed to the Western Front, where in the fall of 1944, the German retreat toward the borders of Germany was underway. After breaking out of Normandy, Anglo-American forces were advancing across France, seizing towns one after another. German units attempted to organize a defense on available lines, but the balance of power was not in their favor. In this situation, the task of holding back the Allied offensive fell to the 3 Sturmtiger self-propelled guns of the 1001st Company. The equipment was sent to a sector of the front in the area of Düren and Eschweiler, where troops were trying to hold the remnants of the Siegfried Line fortifications. This system of concrete pillboxes and engineering obstacles had been built back in the 30s as a barrier on the western borders. However, after a long time without proper maintenance, many structures had fallen into disrepair and the trenches had caved in, so positions had to be urgently restored. American forces attacked methodically, bypassing strong points and using their numerical advantage. Tank units operated with the support of infantry, artillery and aviation, which was constantly in the air. Amid a shortage of personnel and resources, the arrival of heavy assault guns was supposed to strengthen defensive potential. The crews received orders to destroy fortifications that had already been captured by the Americans and turned into strong points. Thus, German forces were forced to destroy their own defensive structures. The vehicles approached to a distance of 220 to 330 yards and opened fire, demolishing reinforced concrete structures with powerful explosive charges. But far more often, these machines were deployed against enemy tank columns instead of static fortifications, exposing the weapon's critical flaws. As a group of tanks moved, flanked by infantry and scouts, the crew struggled to calculate the necessary lead. Once fired, the rocket often missed the moving target completely, exploding some distance from the road. Sometimes the enemy kept right on moving, unaware they were even under fire. Reloading took about 7 or 8 minutes. By that time, the column would have covered plenty of ground, dispersed or found cover, making a second shot practically useless. Meanwhile, American artillery would spot the position from the smoke and dust and open up with intense fire. The crew had to relocate immediately, resulting in a complete waste of ammunition. Yet there is one recorded episode that demonstrated just how dangerous this vehicle could be to armor under the right conditions. In March 1945, one of these self-propelled guns took up a position on a narrow village street, lying in wait for the enemy. Soon a column of 3 Sherman tanks appeared, moving in tight formation. The range was only about 85 to 110 yards, minimizing the chance of a miss, despite the rocket's usual inaccuracy. The gunner took careful aim at the lead vehicle. The rocket struck just under the turret of the first tank, causing a massive explosion that completely obliterated the vehicle and threw the turret a considerable distance. The shockwave and debris hit the second tank, just 33 feet behind. Its armor was breached, sparking a fire that eventually detonated its ammunition. The third vehicle tried to retreat but took damage to the engine compartment. It stalled, and the crew abandoned the machine. Taking out 3 tanks with a single shot was later used by German propaganda to tout the effectiveness of this new weapon. The winter of 1944 to 45 on the Western Front was a period of relative calm. After the Ardennes offensive stalled, the front line stabilized for a time as both sides focused on rebuilding their strength. 3 vehicles from the 1001st Company made it through this phase without combat losses, despite constant technical plagues. Regular breakdowns of the transmission, engine, and aiming mechanisms made operations difficult, but repair crews kept the machines running, sometimes cannibalizing parts from damaged Tiger tanks. March 1945 marked a massive Anglo-American offensive aimed at crossing the Rhine and driving deep into Germany. The Wehrmacht's defense was crumbling due to a critical shortage of manpower and resources. Reports poured in about breakthroughs along the front and garrisons being encircled. Amidst the general retreat, the 3 surviving self-propelled guns fell back with their units, periodically firing on the advancing forces. The crews continued to resist simply because there was nowhere left to run. driven by a desire to defend their territory, despite the inevitable strategic defeat. Every shot delayed the American advance, buying time for the infantry to organize a withdrawal to new defensive lines. By mid-March, German forces had been pushed back across the Rhine. Crossing the water was complicated by destroyed bridges and constant pounding from enemy aircraft and artillery, leading to heavy casualties. 3 of the company's vehicles managed to cross. They were ferried to the east bank on barges under the cover of darkness when enemy aircraft were grounded. The operational objective shifted from offensive to defensive, holding back the enemy and preventing them from crossing the river. However, Allied forces massed their strength and prepared their landing craft. The crossing of the Rhine began in late March, launching simultaneously across several sectors. The German defense was breached, and the retreat continued deep into Germany itself. The Sturmtigers brought up the rear, covering the retreat and firing on American tanks and infantry at the crossing. Rocket supplies were running out fast, and restocking them had become a logistical nightmare. Production of the 380mm rounds was limited to specialized factories that were now either bombed out or already in Allied hands. Ammo depots had been cut off by the advancing troops. Crews tried to scrounge up shells from rear supply lines or abandoned stockpiles, but they usually only found a few at a time, while a full load was 13 rounds. On February 28th, a vehicle from the 1001st Company ground to a halt with a critical transmission failure. The mechanic took one look and realized it couldn't be fixed in the field. It needed to be towed back to a factory for a full replacement, but with American forces closing in, there just wasn't time. Attempts to start the engine to move it failed, so they abandoned it right there, where it was later found by the enemy. That first captured unit was shipped off to the United States for study, while the other 2 vehicles remained in action. April proved especially tough due to a critical fuel shortage. These heavy vehicles consumed fuel at an alarming rate, and the number of available refueling points was shrinking by the day. Ammunition had run dry earlier that month, making the self-propelled guns essentially useless in combat. On April 10, 1945, the commanders of the last 2 vehicles decided to stop fighting. They were out of gas, out of shells, and the front line was in chaos. The crews rigged the fighting compartments with explosives, set the fuses, and pulled back to a safe distance. The blast tore the machines apart, blowing off the superstructures and shattering the hulls. A few hours later, American combat engineers examined the wreckage. Despite the damage, the Allies were intrigued by what they saw. As of March 1, 1945, German units had 13 of these vehicles on the books. Another 3 were in storage, and 1 had already been lost in combat. That count didn't include the prototype, which was written off in October 1944 after the fighting in Warsaw. Throughout March and April, most of these self-propelled guns met a similar fate. Crews abandoned them because of mechanical breakdowns or simply running out of gas and ammo. Only a few were actually destroyed in combat. After the war, Allied forces rounded up the surviving examples. A few relatively intact vehicles were shipped to proving grounds in the United States and Britain. Their experts took a close look at the launcher design, the rocket-propelled rounds, and the armor plating. One captured unit eventually ended up in the Soviet Union and is now on display at the Kubinka Tank Museum. The story of this machine stands as an example of an ambitious engineering concept colliding with the harsh realities of war. Of the 18 units built, only a fraction saw active service, and rarely for their intended purpose. Its massive firepower was negated by poor accuracy, slow reload times, and mechanical unreliability. A weapon designed to storm cities was mostly used during the retreat to hold back the enemy.